Thank you very much, David, and thanks to everyone for coming. It's wonderful to see such enthusiastic support for the forests of New England, for the museum, and for the Alumni Association. So I would like to talk about the forests of New England tonight. This map gives in color all the forests of North America, and I'm going to argue that although New England comprises a relatively small part of that whole, that much of what I have to say works for the entire eastern forest, and a substantial amount of what I argue in terms of some of the threats and some of the opportunities for conserving forests pertains to the whole. The information that I'm going to talk about tonight, and to give you some background on that, I'm going to show you a few slides. Much of it comes from research that's conducted at the Harvard Forest. We are a National Science Foundation funded long-term ecological research center, and we are going to become one of the new National Ecological Observation Network centers. It's funded by the National Science Foundation. We are a living laboratory and classroom of 3,500 acres that we control, but really our purview covers all of New England and beyond. Research that we do, the most intensive work that we do is centered here at the core of the Harvard Forest. The Prospect Hill Tract, and these boxes and arrows gives you a sense of the busyness of that forested landscape. The boxes at the right list the Harvard scientists, Harvard forest scientists, the many Harvard faculty, and just a few of the many institutions that conduct work here on a regular basis. A surprising amount of what I'm going to talk about actually, though, comes out of fundamental research that's conducted by undergraduates who are working with faculty and other science mentors in an ecology program that we run every summer. Remarkably, the interest in this subject, the passion for this kind of work is incredibly strong in the undergraduate community. For the 35 slots that we offer every summer, we have in excess of 650 applicants. And so you can see that there's a craving for firsthand experience doing research. And the quality of this research is such that the students go on and present at national meetings, their mentors present the students' work at national meetings, and much of it does get published. We have a tremendous amount of research infrastructure at the Harvard Forest. Some of it's new, some of it's old, some of it's pretty and elegant, some of it's not. Some of it's just purely nature functioning in a way that we can study it. And then there's an archive. The single greatest value of the Harvard Forest, other than being one of the most intensively studied forest landscapes in the world, is that people have been conducting the kind of work that I'm going to talk about for more than a century. And you can't buy history. You can't buy the kinds of archives, the kind of long-term data that accumulate from year after year, students and faculty and visiting researchers going out and taking notes on forests and the way that they change. And so the Harvard Forest specializes, and the essence of my talk is going to deal with the understanding that we get about ecology, about nature today, based on hundreds or thousands of years worth of research going back thousands of years, to understand the forces that have shaped nature to today, so that we can incorporate that historical understanding plus our current everyday studies in trying to anticipate how things are going to change into the future and how we can best augment those activities, conserving nature and managing nature well. So that's the essence of the Harvard Forest educational and research approach, and it's very much what I'm going to talk about tonight. One of the new projects that we're involved in also is very strongly tied to what I'm going to talk about tonight. It's an effort that's coming out of the long-term ecological research program, a consortium of 25 sites across North America, in which we're leading an effort which is really trying to envision future scenarios of landscape change based on our understanding of natural and cultural dynamics, the kinds of decisions that people are making in the face of the kinds of environmental change that we're confronted with or we are actually experiencing. And so again, much of what I talk about is focused on New England, but is grounded in an understanding of North American forests that's based on a much larger amount of work. So let me start by looking back in time. And the intent with this diagram is to make one or two simple points. It's not to understand the detail of this diagram, which shows an array of tree species on the left, and then time as an axis, the last 15,000+ years going across the bottom. But it's to look at this and to make note of a couple of things. First is that there are one or two periods of very significant and very rapid change. It's a period about after the early period of spruce forest, which is shown on the bottom, in which is a rapid change to pine forest, and then a change to a mixed forest of hardwood species and conifer species. And then there's a very rapid change just in the very top last little bit of this diagram, which corresponds with the arrival of European people. But I would argue that the bulk of the story in here is about very slow, ongoing change. In other words, the New England forests have experienced very long-term periods with relatively little change in the relative abundance and certainly the overall composition of our forests. Even a relatively recent arrival to our landscape like chestnut, which is noted as being a laggard in making its way up to New England, has been in New England for 3,000 years. And so when people talk about change being constant, they're correct. But that change is not constant. Forests are always changing, but the rates vary considerably, and a lot of it is very, very slow. But there are some notable periods when there's significant change. And some of that is very relevant to what we're concerned with and think about today. The most notable in the last 8,000 to 10,000 years is an episode that's shown here. And this is a curve of the abundance of hemlock, which goes from 10,000 years over here up to the present. And you can see this absolutely remarkable drop in the abundance of hemlock. That occurred about 5,000 years ago, and it took somewhere between 10 and 20 years to occur. And the map then shows, with the green, the relative abundance of hemlock before this decline, and then the red dot shows the abundance afterwards. So this was a phenomenon that occurred all across New England, across Massachusetts, in fact, across New England, in fact, across the entire range of hemlock. Now, the first interpretation of this was a really fascinating one, and it's one that still is viable today. It was offered by a graduate from Radcliffe, who then went on and got her PhD here. Her father was a professor in geology, Kirk Bryant, and she studied at the Harvard Forest doing a paleoecology PhD thesis in the 50s. And in the 70s, she looked at this phenomenon and she suggested the only way that you could have that rapid a change across the entire range of a species is if a new organism confronted it, a pathogen or a pest, and it just decimated the populations. And that thinking prevailed. It was fascinating, and it challenged us because here was the introduction or the occurrence of something which is very relevant to the kinds of things that happen with the introductions of new organisms in our landscape here. Very recently, we've done quite a lot of work out on Martha's Vineyard, Nantucket, Cape, and some of the other coastal landscape. And we've noticed that if you take this green curve, which is the hemlock decline, about 5,000 years dropping down, and you look at oak populations on the Cape and islands, they actually do exactly the same thing at exactly the same time. And looking further with a group of other scientists, we've been able to show that there was actually significant climate change. including warming temperatures and very significant droughts that led to major lowering of water levels in ponds. And so we've now modified Margaret Davis's original interpretation to suggest that it actually was the interaction of rapid climate change and perhaps a biological agent that actually killed these trees. And the fact that it happened in more than one species suggests that it's an interaction between different organisms and an environmental change. Now, this is very relevant for today because there are very few scientists who expect that climate change per se, warming temperatures, is going to kill lots of tree populations. But it's going to be the interaction between that and natural disturbances and biological organisms, as well as human activity, that are going to lead to the decline of those populations and their replacements by other populations. Now, the interesting thing is that as the climate changed and conditions went from dry and warm and got moist again, both of those populations recovered. The bad news for us, taking that as an analogy for today, is it took well over 1,000 years for that to happen. Now, if you go out onto the island of Martha's Vineyard today and you stand on North Road and you, at sunset, and you look to the east with the sun behind you, you see the middle ridge of the moraine on Martha's Vineyard. And that gray color on the top and the gray color at the bottom is dead oak trees. There's about a mile-long expanse, continuous, in which almost every single oak has died. And that occurred due to the outbreak of an insect, a caterpillar, that over 3 successive years defoliated those oak trees at a time that coincided with a drought. And so quite an interesting analogy to what happened back then. Interestingly, the major population that's taking benefit from this, the green trees down in the bottom left and the few that are poking out at the top, are of course other species in oaks, and one of the major species is beech. Now 5,000 years ago, interestingly on the Cape and Islands, in the area of Falmouth and all across the west side of Martha's Vineyard, for example, oak populations were replaced by beech. And there were beech forests all across that landscape. Hard to imagine today, unless you've been to the island of Noshan, which has about 1,000 acres of pure beech and a great analog for the way that looked. So here we have an analogy for something that happened in the past, and the past then gives us some understanding for the way that climate change interacting with other forces might play out in the future. Now, looking in the past, there's other disturbances and processes that have shaped the New England landscape. One of the notable ones that we've been thinking about recently a lot because of Irene is hurricanes. We've done a lot of research at the Harvard Forest reconstructing the meteorology of every hurricane since 1620 to the present, and then running those storms through the landscape to reconstruct what their impact has been. And down here is a graph that shows the relative magnitude of those storms as they affected, in this particular case, it's the coastal landscape, but it would be pretty similar to the Boston area as well. By comparison, Irene, of course, disintegrated as it came onto shore and made its way into New England. It would be equivalent to about the lowest one of those bars. There are a couple of points to take into account here. One is that storms like this hit New England infrequently, much more frequently in the coast and much more frequently in the southeast than in the northwest. When they do, they can be really transformative in terms of the kinds of damage. The type of damage that we saw recently from Irene pales by comparison to what could happen in a major storm. And interestingly, the single greatest storm that ever hit this region occurred in 1635, 15 years after the Mayflower, and it was observed by the leaders of both the colony at Massachusetts Bay and the colony at Plymouth. And from their descriptions and others, we can actually reconstruct both the meteorology and some of the disturbances quite well. There was, for example, a 20-foot surge of water in Buzzards Bay. And Narragansett Bay was flooded to the equivalent of what happened in the 1938 hurricane. So these maps just show the reconstruction to show this concentration of the kind of maximum damage and the number of storms that occur. So New England is a moist climate. It's an area where fires are relatively unimportant, and so the major natural disturbances are meteorological and then climatological, and then the interactions that those have with other types of disturbances. The kinds of impacts that can come from these storms is shown here. This is actually a site that's well inland and affected by the 1938 hurricane. This is a magnificent old-growth forest that is owned by the Harvard Forest, conserved to protect it from logging, and it was entirely blown down in 1938. This map shows the extent of damage across New England from the 1938 hurricane. This was a time when, by and large, the forests were more sparse and smaller than the forests are today. So we would expect at least this amount of damage from a 1938 equivalent type of storm to occur today. Now, fortunately, the director of the Harvard Forest prevailed against individuals who were interested in salvaging that forest. And you can go back up to that landscape today and walk through it, and it's a magnificent site. It's magnificent because it contains structures like standing dead trees, 3-foot diameter at the base that go up 100 feet above the regrowing trees, and intact logs that have been lying on the ground for 70 years. The reason we don't have that kind of structure elsewhere in New England is because of our history of land use, land clearance, and logging. It's only in places where you have old-growth forests that can then interact with the kinds of natural disturbances that might normally prevail in this landscape that you can generate that kind of impact. Now, of course, one can't talk about the natural processes, the pre-European processes in this landscape, and ignore humans who had been here for at least 10,000 years. This map is one group's attempt to kind of show some of the concentrations and rough estimates for population densities. And there's been much talk recently about the dramatic impact, the kind of managing effect that Native Americans had in many parts of the Americas. And while that is true in many landscapes, it's not a story that plays out particularly effectively in New England. Because up until just a few centuries before European settlement, this was very much a highly mobile, hunting-gathering population that didn't live in established villages, wasn't conducting agriculture, and therefore had little rationale, motivation, or population density that would lead it to disturb vast acreages and certainly clear vast acreages. Agriculture, maize, corn, and beans and other crops that we associate with Native American agriculture arrived within the last 500 to 1,000 years before European settlement, and were just rudimentary supplements to an established diet that had prevailed for thousands of years. So these people were very much part of this landscape. They were very much having an influence in shaping this landscape and responding to its changes. But they weren't having an overwhelming effect, and they weren't altering the basic structure and composition of the forest in any way like natural process, climate, or subsequent human populations would. And so at the time of European settlement, New England was really a forested landscape largely dominated by old forests and the array of species that are shown here that were reconstructed with a variety of historical techniques. Since European arrival, of course, everything has changed, and the rate of change in our forests has been exacerbated tremendously. Let me just go through a few of those examples. as I was walking in, or as somebody else was walking in with me, they said, well, I hope you will end up talking about the hemlock woolly adelgid. And here is the hemlock woolly adelgid. Again, an interesting biological agent for the way that it interacts with climate change. The adelgid arrived in Virginia, has spread, has recently spread very rapidly to the south, where in the matter of a year to 3 or 4 years, it kills entire populations of hemlock, and they're replaced by other species. As it moves progressively farther north, its populations get affected by cold temperatures. Its actions are much slower and much more progressive. And populations of hemlock trees can live for 10 years, 20 years, or longer in the presence of hemlock woolly adelgid. Its northern range now is probably limited by extreme cold temperatures in the winter. And so its actions will play out in accordance to the way that climate changes and this particular species interacts with those climate changes. Where hemlocks are killed, of course, it's a stark scene, and yet the forest is very, very rapidly replaced by other species. And in many places where hemlock is not the dominant, most people walking in the forest, interestingly, don't even notice that the hemlocks are disappearing. There are many other species that we've heard a lot about. One of the most notable invasive species is Asian longhorn beetle, brought in on wood supplies that are coming, pallets and other materials that are brought in from Asia. Map up at the upper left shows some of the notable outbreaks that have occurred, all of which have been controlled. The most serious is this one that's occurred most recently in Massachusetts, in Worcester. Serious because it probably was 10 years before it was detected, and serious because it spread into forested areas, and thousands of trees, tens of thousands of trees have had to been eradicated, cut, and removed in order to try to control this. And it's very clear that as of yet it's still not controlled as new populations are being found. So we have a range of biological agents and a range of other activities that have occurred with the movement of people and movement of materials, the arrival of a European civilization, new civilization that brought lots of materials with it. But the single greatest change that has occurred in our landscape and is still occurring in our landscape is that which is generated by direct human activity. So the graph at the left, lower left, shows what's really one of the most remarkable stories of forest change in the world, because it's a story of forest decline, forest conversion to agricultural scenes like this. This is a photograph taken in the late 19th century in the town of Petersham, Massachusetts, which is where the Harvard forest is. So a kind of continual clearance of the forest as the population of New England increased, and a forest clearance that was similar in southern Maine and Vermont and New Hampshire as it was in Connecticut, Rhode Island, and Massachusetts. And that clearance peaked, with agriculture peaking, really at the time of Henry David Thoreau, the mid-19th century. And then starting at that point, forests started to come back as the human populations moved into urban settings, as agriculture shifted to other parts of the country, and as fallow agricultural land was naturally reclaimed by trees that readily spread into a landscape that welcomed it. It's very difficult to keep trees out of the New England landscape, and they marched right back in and reforested the landscape, such that this is that same scene in Petersham, Massachusetts, 100 years after this was taken. A really remarkable, completely unpremeditated, inadvertent environmental success stories in many ways. As the forest came back, it created a very natural appearing scene, and just to illustrate that with a non-forested landscape, this is a paired set of pictures from Nantucket showing what happens when you take sheep and remove them from the landscape. So when you remove agriculture and you stop managing the land for agriculture and allow nature to come back. This comes from a marvelous book by Peter Dunwoody. But the same thing happened in forested landscapes as well, and there were a remarkable series of changes. Our lakes changed, our wetlands changed, as our forests changed. And as they changed, the habitats that they represented changed, and so wildlife changed as well. So the graph on the left shows changing abundances of different groups of wildlife, or representative species, of different types of response, that are responses in large measure to the changes in the habitat that's available for them. But of course, it's also conditioned by hunting pressure and changes in human attitude. And so just to note on that, there's a group of species like wolves that were extirpated that haven't come back. There's a group of species like bear, which were extirpated and then did come back, or like moose, which have come back on their own. Some of those species were aided, like beavers, which were reintroduced to western Massachusetts. There's another group of species like deer that were almost extirpated and have, of course, come back in great numbers. And then there's a small number, but a remarkable number of new species like coyote, which are newcomers to this landscape, in the case of coyote having migrated all the way from southwestern United States, all across much of North America, and certainly all across Massachusetts. And at the same time, it's important to recognize that there were a whole suite of organisms, mostly small organisms, but birds and small mammals and insects certainly, that thrived in the open agricultural landscape of 19th century New England. And those are represented here by a kind of bobolink and meadowlark, these grassland bird species or open land species. And interestingly, that group of species is one of the major conservation concerns in New England today, and it leaves us with a great dilemma. What do we do with those species which are threatened by the inadvertent recovery of natural vegetation? But it provides us with some really remarkable research opportunities. No one has ever studied moose in oak forests because moose are largely restricted to a northern kind of boreal forest landscape, and now with 700 to 1,000 or so resident in Massachusetts, many of whom are centered in the Petersham area, there's a phenomenal opportunity to see what happens when this new type of very large organism that consumes a tremendous amount of food comes in and starts shaping the landscape. So I'm going to shift and talk a little bit about how we deal with the changes in the landscape wrought by people. And I should go back, but since many of you have a copy of this Wildlands and Woodlands report, and if you don't, I'll suggest that you get it and you look at that forest area curve again, that remarkable recovery of forests in each of the New England states. You'll notice that for every single New England state, that curve is now heading back downward. So one way I like to look at it is that history has provided New England with a remarkable gift. Inadvertently, we have recovered a substantial amount of our forests. And the question that I'd like to address for the rest of the talk is, what are we going to do with that forest? Right now, most people, when asked, and certainly most people internationally who know this as a remarkable conservation story, assume that the pressure is off New England forests. But in fact, our forests are declining at a very rapid rate. So as I move into that, of course, we want to look at forests and say, well, what motivates us to think in a positive way about them? And there are many emotional and many psychological and many spiritual reasons. There also are many direct economic benefits that come from that. And unfortunately, fortunately for us, but unfortunately because we haven't derived really effective ways of telling the stories, there are many tremendous economic benefits that aren't valued effectively and so aren't conveyed very effectively. And the single best example of that is one that affects the entire Boston metropolitan region, which is the Quabbin Reservoir. Through tremendous foresight, more than 80% of that watershed has been purchased and protected. and it now filters the water that comes to Boston and allows Boston to derive all this clean water without building a major filtration plant. Daily, no one thinks about that, and yet the conservation value of that forest above and beyond that is tremendous, because wood products come out of that, recreation is centered on it, and wildlife habitat is ample throughout that entire watershed. There are other benefits, and one of the talks that's coming up in this series is a discussion led by Steve Wofsy and Andrew Richardson here at Harvard on this story, which is the fact that these forests that occur in New England, which have come back in the last 100 to 150 years, are relatively young. And so they're growing at a relatively fast rate, and so they are sucking carbon dioxide out of the atmosphere and storing it as wood. They are, in the scientific term, sequestering carbon. And this curve at the left is a remarkable curve. It's the longest record continual measurement of carbon uptake by a forest anywhere in the world. It's an effort led by Steve and by Bill Munger here in EPS at Harvard, and it's centered at the Harvard Forest. And the remarkable thing about that curve, if you look at it, you can see that it goes upwards. That means that the amount of carbon in that forest is going up. It's taking carbon dioxide out of the atmosphere. You can see the squiggles, which are the seasonal pattern of uptake in the summer and release in the fall and winter and early spring, and then uptake again, and uptake is greater than release, and so it's a constant upward trajectory. But it actually isn't constant. If you look at that curve, you can see that that curve is going up at a more rapid rate now than it was in the past. And so even though this is a 100-plus-year-old forest, the rate at which it's taking up carbon is increasing. And when you take that little pixel here of that forest and you spread it across a large measure of New England, and then you spread it across the eastern U.S., which shares this history of forest recovery, you recognize that this is absolutely an immense carbon sink. And Steve and Andrew are going to wrestle with the question as to how big a sink it is, how long it's going to continue to operate, and what we might do to assist that. But so there are major threats that are coming now from this active deforestation. Our forests are being fragmented and actually converted to a whole range of other land uses. I love this. It's kind of the Emerald City view. This is the Mohegan Sun Casino in southern Connecticut, sticking up out of the forest. But the map on the left shows population growth in New England, with red being the most rapid, centered west and north of Boston, but going all the way up and including the Burlington region. And this is the U.S. Forest Service, now dated, attempt to capture what the development pressure will be across New England. So it's rapid, and in recent years it's been increasing. At the same time, there are remarkable changes in ownership that are going on with our forests. Forests are changing hands all the time. Most of the times when forests change hands, ownerships get increase in number, because people break their parcels up, they develop part of it, or they sell multiple parcels. But this is one remarkable story. It's the state of Maine, and it's the change on the left from a forest landscape in which northern Maine is owned by old timber companies or families, and timber companies that are operating that land for a profit, using it for a long term, managing it for timber products. And that change has occurred as much of that land has been sold and bought by a whole range of different types of investment entities. Groups that are interested in getting a financial yield on a shorter time frame, or a greater yield over a longer time frame than the traditional long-term owners. So New England is very much up in play in terms of ownership and in terms of its future. So if we look back at New England history, there's two remarkable stories that involve both people and nature. One is this story on the left, which is everything in green is forest. 82% of New England is forest. It's the most heavily forested region in the United States. At the same time, and that's happened because of shifts in human activities and a lot of recovery of forests. And almost all that region outside some of the more intensively managed areas in Maine, the forests not only greater in extent, but they're continually getting older. And then there's this other story, which is 100-year plus history of people in this region attempting to preserve and protect that resource for the future. And so this is a remarkable story because New England has been a leader from the earliest days in terms of articulating a strong conservation ethic and leading the way in terms of advancing conservation success. And so there's more than 20% of New England which is currently conserved. But I think you can see if you put those two maps together, and if this is all of New England that we keep permanently conserved, that is conserved from being developed and fragmented and changed to other types of land use, that we're going to change the nature of that map on the left very significantly. And so we have not yet developed an effective way of connecting these blocks or increasing the total amount of area that is conserved from long-term future development to ensure that we will have these forests into the future. And there's a tremendous amount of expectation in the landscape that things will stay the way they are, and yet the recent history shows that actually this kind of development pressure is relentless. So I'd like to spend the last part of my talk just articulating a few answers to this question. So given this history, and given the kinds of threats that are facing our forests, what can we all do, whether we are students or faculty or alums or museum volunteers or museum members or people in any other category? And first, to point out that the conservation success that I showed in the past is due to these people. It is due to all of the landowners, all of the conservation land trust members, all the passionate environmentalists who have made a decision to go out and conserve nature for a variety of purposes and in a variety of ways. And one of the remarkable things about New England that I can illustrate just using the southern three states is that there is a remarkable capacity for conservation. Because of this long history and because of the development, the formation of hundreds of land trusts within this region, there's everything from local town land trusts and local boards to regional land trusts and conservation organizations, statewide entities, and national entities that are operating in the New England region and capable of advancing this kind of conservation activity. So the capacity is there to actually achieve much more conservation than we have in the past. And just as an example of that, to go to the town of Petersham, Massachusetts, where the Harvard Forest tracts are shown as this red hashing, you can see the conservation landscape that is developed in addition to Harvard-owned lands in here, with the green being areas that were conserved by 1990, and the blue being areas that have been conserved in the last 2 decades. And just this past week, I saw a proposal to conserve another 2,000 acres in this town. We at the Harvard Forest are actively involved in that effort, developing maps like this, sharing science information, helping to raise money, especially in those cases where we conserve land directly around the Harvard Forest to protect this classroom and laboratory that we have. So there is an awful lot going on in the landscape today. But starting in Massachusetts and then looking across New England, a group of scientists from throughout New England got together and decided that, you know, there actually was an opportunity and a need to do something more than just study nature and study these changes. We could use the history and the science that we had accumulated and articulate a vision, a plausible future for New England that could be achieved if the conservation capacity that exists out there were applied more actively. So this is the list of institutions and authors who came together in that most recent report. They come from every state in New England and many different kinds of organizations. And this is what the proposal boils down to. Green is forest, red is development, yellow is open land, agriculture, and other types of open land. And this light green is conserved land. And we made a simple but relatively bold proposal that by doubling the pace of conservation over the next 50 years, it would be possible to conserve 70% of the New England landscape in forest, given the fact that we're starting at 80%. And the interesting thing is that you can achieve that while still doing nothing to the rate of development. So in other words, this graph just shows development occurring as it has in the past. We recognize that hand in hand with good conservation goes more effective development, that it makes an awful lot of sense to focus the development, to generate more clustered development, to renovate old mill towns and existing very livable urban centers, than it does to go out and establish new residences in a willy-nilly fashion all across the landscape. And so that this could actually be augmented by some very interesting strategies for development. So the proposal that's out there is to protect, for a variety of purposes, 70% of the landscape. And if that were to happen, one would end up with a future in which there would be a forested landscape in New England that varied in the density and extent of forest depending on where you were, and of course on where we are starting today in terms of existing amount of forest and developed land. So with that proposal, there's always the question of, well then, how is this land managed? In other words, what is conservation achieving? And I should point out, as was stated on the map previously, that one of the most effective means of conservation these days that's emerged is that of developing conservation restrictions or conservation easements, in which the current landowner or some other landowner continues to own the land. A private entity or private individual or family owns the land, and yet the development rights for that land have either been donated to a conservation organization or purchased by a conservation organization such that the land can be developed in perpetuity. And that allows the land to still be owned and managed and appreciated by private individuals or organizations in a variety of ways, and in a number of ways that continue to allow taxes to be paid on those lands to the local municipalities. But it achieves long-term conservation. So the question is then, how would those lands be managed? We assume that since the majority of ownerships at one time or another involve active management, that most of that landscape would be managed into the future. There's a variety of ways that that could be orchestrated. There's a variety of ways that management could be improved. But it's likely that if private individuals and organizations own their land, whether it's for timber purposes or recreation or wildlife and conservation objectives, they will manage their land. But we note that the single most underrepresented type of forest in New England today is one in which there is no management whatsoever, no active management. The management decision has been made to stand back and let nature operate under the prevailing environment and conditions. That's the way that most of our landscape operated until 400 or 500 years ago. But there's very little of the landscape that does that today. And there's great interest in seeing the reformation, the regrowth of old growth forests and those kinds of large landscapes where natural processes occur. There's also strong scientific and educational rationale because there's an awful lot that land managers can learn from studying wild places and adapting some of their management so that it takes advantage of that information. Now, in developing this, we're continuing to articulate the fact that there is an increasing interest in growing more resources in our own backyard, whether those are agricultural or forestry. And so certainly built in with this is an appreciation for an expectation that there will be strong emphasis on conservation of agricultural lands and other types of open lands. So how does one advance this kind of activity? Well, we are scientists and educators. We are not actively going out and conserving the landscape. But we have developed a series of communication skills, and we are trying to interact more effectively with land managers, decision makers, and policy makers. And so we made a good attempt to try to get this report well covered so that there'd be an opportunity for individuals to discuss it and organizations to determine whether or not they wanted to use these kinds of ideas to apply to their own groups. And I wanted to point out, since there is a moderate composition of alums in this audience, that some of the greatest support for this effort and some of the strongest conservation action in New England in the distant past as well as the recent past associated with our ideas has come from people associated with Harvard and a variety of schools. And so I'm just going to articulate 3 examples. One is this fellow, Charles Foster, also known as Hank, who started an organization called the New England Natural Resources Center, but has been involved in a wide range of conservation enterprises, was the dean of the School of Forestry down at Yale, has been the Secretary of the Environment here in the state of Massachusetts, and many other things. Well, this is a resolution honoring his work by all the governors in New England states that was released within this last year. And he did that because in response to the Wildlands and Woodlands effort, he put together a book articulating the achievements and the possibilities for conservation in each of the New England states. And he used that to deliver to the New England governors on their centennial of their first meeting. And he reminded them that their first meeting, they were addressed by Gifford Pinchot, who was at the Yale School of Forestry and was the head forester for the United States. And he argued that they should have conservation at the top of their agenda. So on the basis of Hank's book and his argument, the New England governors adopted conservation at the top of their centennial agenda and have now made a very strong argument for advancing it.